acid-base concept. I'll make this lecture super easy. Click the subscribe button below and get access unique lesson Arrhenius acid-base concept. Commonly, we use acids and bases both as laboratory chemicals and in our homes. Some common householding acid bases are mentioned here. In lemon, we have citric acids and its formulas C6H8O7, and which this one is one common household acid. The second one is carbonated beverage, in which carbonic acid is found, and its formula is H2CO3. And the third common household acid is acetic acid, which is found in vinegar, hydrochloric acid, which is found in our stomach, sulfuric acid, which is the leading industrial chemical, nitric acid is also the leading industrial chemical, and some common bases are sodium magnesium hydroxide, which is found in syrup. And now let us discuss Arrhenius concept of acids and bases. Arrhenius is a Swedish chemist. He studies the effect of acids and bases on water. And acids, according to Arrhenius, acids are a substance that dissolve in water and release hydrogen ion or proton or hydronium ions. According to him, any substance that dissolves in water and release hydrogen ion, proton or hydronium ion, we call it acid. This one is acid and this one is water. Here is some example. Hydrogen chloride gas dissolve in water. Finally, it releases hydrogen ion or proton and chloride ion. Therefore, hydrogen chloride is an acid because it dissolves in water and release hydrogen ion. The second example is nitric acid dissolve in water and produce nitrate ion and hydrogen ion or proton. So nitric acid is an Arrhenius acid because it dissolves in water and release hydrogen ion. As I told you, HCl is an acid, Arrhenius acid, because it dissolves in water and releases hydrogen ion or proton. And nitric acid is an Arrhenius acid because it dissolves in water and releases hydrogen ion or protons. Methane, though it contains hydrogen, is not Arrhenius acid because it doesn't dissolve in water and release hydrogen ion. Benzene, though it contains hydrogen, it is not Arrhenius acid because it doesn't dissolve in water and release hydrogen ion. Therefore, substances that contain hydrogen may not be Arrhenius acids. Now, according to Arrhenius, bases are a substance that dissolve in water and finally it must release hydroxide ions. This one is when sodium dissolves in water. And here is different example. Sodium hydroxide dissolves in water. It produces sodium plus hydroxide ion. Therefore, sodium hydroxide is an Arrhenius base because it dissolves in water and release hydroxide ion. That's why we say sodium hydroxide is Arrhenius base. Because it releases hydroxide ion. The second example, barium hydroxides dissolve in water and finally it produces barium plus 2 ions and hydroxide ions. Therefore, barium hydroxide is an Arrhenius base because it releases hydroxide ion when it dissolves in water. any substance to be Arrhenius base, it must dissolve in water and it must release hydroxide ions. Copper hydroxide, aluminum hydroxide, and iron hydroxide, are not Arrhenius base because even though they contain hydroxide ion, they don't dissolve in water and release hydroxide ions. All group 1A and group 2A metal hydroxides are Arrhenius base except barium hydroxides. Therefore, substance that contain hydroxide ions may not be necessary Arrhenius base, as we have mentioned above. For example, copper hydroxide, aluminum hydroxides. Arrhenius acid and base concept has its own limitation. The first one, Arrhenius acid-base concept limited or restricted to aqueous solution. It only works in water. Without water, it doesn't work. 1. Ammonia acts as a base in water, but Arrhenius couldn't explain this one, why ammonia acts as base in water. The second one, it cannot explain acid-base reaction in an aqueous solution or in a gas state. There are many acid-base reaction in an aqueous solution or in a gas state. The third one, Arrhenius only considered hydrogen ion and OH ions, while there are many acid-base reaction that involves the transfer of electrons, not these ions. Thank you.